Hi everyone, now we are at Multivariable Calculus, lecture number 3. So in this class we are going to discuss about partial derivatives. So first let us complete partial derivatives of a function of two variables here. Then I will enter slightly into three variables. First two variables. Okay. So partial derivative with respect to x first. Why the word with respect to x? Why? Because if you look at for example the function f of x is equals to some x square plus 2x minus 3 by 2. For example, if this is a function, then what is df by dx? Then with respect to x, we have to do the derivative, right? That means 2x plus 2. That's it. But if the function is like this, f of x comma y is a function of two variables, like x square plus y square, for example, function of two variables. Now, uh, by writing like this, it is meaningless, df by dx. Why? Because here two variables are present. With respect to x, you are doing, right? But there are two present here. With respect to which one? So what is the derivative of this function? First of all, question is what is the derivative of this function? Then immediately your next question is with respect to which variable, x or y. So that is the matter because two variables are present. X and y both are variable here. Okay. That's why now I am using the word like this, dou f by dou x. This is called dou f by dou x. Dou f by dou x. That means this is called partial derivative sign. It is partial derivative sign. Okay, partial derivative sign. See the word partial. Why the word partial? Because even though two variables are present in the function here, x and y, you are doing with respect to x. That means you are treating y as a constant. That means you are neglecting y variable. Okay. In this you have to treat y constant. Then x is variable. Y constant, x is variable in this. Understood? Dou by dou x. Similarly, dou f by dou y. Now in this you have to treat y as a variable. Y variable. Okay. Now you have to treat x is constant. Again, with respect to y you are doing, therefore you are neglecting x. That's why it is partial derivative with respect to y. This is partial derivative with respect to y. Partial derivative. So this is partial derivative with respect to x. Because with respect to x you are doing. That's why. So since it is a function of two variables now, derivative function of two variables now, partial derivative of a function of two variables. So that's why two variables present here. Let's say x and y. Now partial derivative with respect to x first. The partial derivative of f of x comma y with respect to x is dou f by dou x. This is a sign. So you're doing derivative of f with respect to x. That means rate of change of f in the variable x only. Two variables are present, but the geometrical meaning of dou f by dou x is nothing but it's a slope, right? Slope in the x direction actually. df by dx means what? Slope of a tangent. But here dou f by dou x means again same slope of a tangent in x direction. Same story only. But what is the literal meaning? The literal meaning of this one is slope of that. Geometrical meaning is slope. The literal meaning is rate of change. Rate of change of f with respect to x. Okay, rate of change of f with respect to x. That means in the variable x only it is changing, not y. Look at y is constant. Y here. Okay, only x plus h and x. So first I have taken x plus h and x I am looking. That means if you look at geometrically, if this point is x, then x plus h must be after x only, right? Provided h is positive. If h is positive, x plus h must be after x only. Now, if I do f of x plus h minus f of x, that means if you take the difference, you will get the variation. The function value of f at x plus h and the function value of f at x. The difference if you take, that is called rate of change. Same thing I am doing here. So with respect to x, the rate of change is only in the variable x you have to look at x plus h, f of x plus h comma y minus f of x comma y divided by h. As h going to 0, this will give you rate of change of f in x. Okay. The partial derivative of f of x comma y with respect to x at some point x naught y naught. Okay. Now same Same thing only, but instead of just writing x and y, you substitute the point x naught y naught. Look at same thing only. This form only. Instead of x plus h, you write x naught plus h and y naught minus f of x naught y naught. Same limit h tends to 0. This gives you rate of change of f in the variable x at the particular point x naught y naught. Notations. The partial derivative of f are simply z. That means you are taking, for example, z is x plus y, you can write like this, or simply f of x comma y is equal to x plus y, you can write like this, no problem. Both representations are correct for the function x plus y. You can write z is equal to x plus y or f of x comma y is equal to x plus y. That means x and y are inputs, okay, and x and y are independent variables. For example, x is 1, y is 1, then what is f value? 2. If x is 1, y is 1, f value is 2. That means indirectly z value only. So if you look at in 3D, if this is x-axis and this is y-axis, x value is 1, y value is 1, then corresponding value you should represent in along z-axis. That means in the space you have to mark 1, 1, 2. This point is 1, 1, 2. X value, y value, and this is z value. Z value is nothing but f value, function value. Okay, so you can write function f of x comma y x plus y, you can write as z is equal to x plus y also, no problem. So therefore, that's why in that context, the partial derivative of f or z with respect to x is denoted by dou f by dou x, or simply fx, f suffix x. If you're writing like this, it is dou f by dou x, partial derivative with respect to x, and dou z by dou x. So when you are using the word dou, that means z is a function of more than one variable, simply. If I'm using the word d, for example, df by dx, if I'm using like this, now f is a single variable function, that is x only. But if I'm writing like this, f is a multivariable function, more than one variable. In that more than one variable, so with respect to x, we are doing a derivative. That's called partial derivative. Okay. So once dou comes, it is a multivariable function. So dou z by dou x means the function z you have to derivative with respect to x, or simply zx, z suffix x. These are the notations. The partial derivative of f or z with respect to x at some point is denoted by same thing only, dou by dou x, but x naught y naught you have to write. After doing derivative, at the end you have to substitute the point, or simply f suffix x at x naught y naught, or dou z by dou x at x naught y naught, or zx at x naught y naught. That's it. The partial derivative dou by dou x at some point gives the rate of change of f with respect to x. This already I told you just now. So this gives you rate of change of f with respect to x, and what we are doing in this with respect to x, when y is held fixed at y naught, that means y is constant now. Okay, so dou f by dou x at x naught y naught. Okay, so x naught y naught, it means since you are doing derivative with respect to x, now treating y naught is constant, so therefore you can do like this also. D, look at, I am writing d by dx of f is a function of x comma y, right? It is a function of x comma y. So x comma y naught I am writing directly. Since you are doing with respect to x, therefore directly you substitute y naught value, no problem. Once you are substituting y is equal to y naught, that means it is a number, some number. Y naught means, for example, let us take y naught is some number 1. So 1 you are substituting instead of y in the function. Okay. Then later you substitute the point x equal to x naught. And this is similar, this is exactly same as dou by dou x at x naught y naught. Or simply d by dx of, since we are doing with respect to x, y we don't want, then substitute y value, y is equal to y naught. Now this is a function of single variable only, that is x only. Because y naught is a number, instead of y you are substituting number. Then it reduces to single variable. For example, look at this function. Y is equal to y naught means I am substituting y is equal to 1. For example, 1 I am substituting, therefore x plus 1. Look at, now z is a single variable function, that is x. Now dz by dx is makes sense now, instead of writing dou z by dou x. Here dou z by dou x is makes sense because two variable, here only one variable, therefore dz by dx here makes sense. Okay, so that's why d by dx is makes sense, since it is a single variable function. After evaluation of this derivative, you will get a function of x. Now instead of x, substitute x is equal to x naught. That's it. It's similar, exactly similar to this one. That's what here written. Y is held fixed, y naught. This is the rate of change of f in the direction of the positive x-axis at x naught, y naught. That means in the direction of vector I. X direction means unit vector I. Y direction means unit vector j. Z direction means unit vector k. Like that. Okay. Next one. Now look at note number 3. Dou by dou x at x naught, y naught, exactly same as what I said just now. D by dx of f of x comma y naught. That means what? Instead of y, I am substituting y naught because you are doing partial derivative with respect to x, right? Same, just now I explained. So partial derivative with respect to x, that means you are treating y as constant, then substitute y is equal to y naught. That's it. Now it becomes d by dx of f of x comma y naught. Now this is a single variable function, f of x comma y naught. Okay, and this gives you the slope of a curve. This is a geometrical meaning, is the slope of the curve z is equal to f of x comma y naught. So this is f of x comma y naught. This is a curve now. For this curve, d by dx you are doing. That means what? You will get a slope. At which point, since it is three variable function, initially it is a three variable function, two variable function. F is a two variable function. If you give x and y value, you will get z value. Therefore, total 3 points: x naught, y naught, and the function value. So at this point, you are getting the slope of this curve. Z is equal to f of x comma y naught. It is a single variable function. That's why it is a curve now. This represents curve. Initially, this f1, f is a function of two variables. It represents, like for example, surface x square plus y square. That is one of the surface examples. So initially it represents 2D one, but now after substituting y is equal to y naught, now it represents a curve. Okay, at this point in the plane y is equal to y naught. Why? Because you are substituting back y is equal to y naught. Therefore, in the direction x you are finding the derivative. In the plane y is equal to y naught. So geometrically it will be like this. Look at now surface. This is a surface. Let's take. Initially it is a surface. Then what I am doing? I am substituting y is equal to y naught because you are doing dou z by dou x, right? That means with respect to x you are doing derivative, therefore treating y is constant. Then substitute y is equal to y naught. Then what will get f of x comma y naught? F of x comma y naught. Now this is a curve, right? Look at this is a curve. The curve z is equal to f of x comma y naught. Look at. Now this is a curve. Okay. Look at this is a curve. Z is equal to f of x comma y naught is a curve. And this one is which one? This one. This blue one is a curve in this surface. Particularly at which point y is equal to y naught. And for this curve, if I do the derivative of this, that means dz by dx. If I do this one, dz by dx, that means you are doing derivative of this one. That means you will get a slope. In which direction? X direction only. Now, so this red color one is a tangent. So this tangent slope is this one, dz by dx. At which point? At this point, x naught, y naught. Look at p of x naught, y naught, f of x naught, y naught. At this point, you are finding the slope. In which direction? X direction only, because you are doing d by dx. In the x direction, you are finding slope. What is this? Is x-axis, right? This is x-axis. Look at this is x-axis, and this is y-axis, and this is z-axis. So this is x-axis. Therefore, in this direction, look at this red color one is a tangent in x direction only, right? Look at this is the red color one is a tangent, and this tangent is in x direction only, and you are finding slope in x direction only. So this is a geometrical meaning of the partial derivative with respect to x. Similarly, partial derivative with respect to y. Same thing. The partial derivative of f of x comma with respect to y is, now we have to look for variation in the y coordinate. In the y coordinate only you have to look at y plus h and minus y. X is constant. Okay. As h tends to 0, this gives you rate of change of f with respect to the variable y. Now f is a function of two variables. Okay. Now the partial derivative of the same function with respect to y at some point x naught, y naught. Same thing only, but at x naught, y naught. That means wherever x you write x naught, wherever y you write y naught. X naught comma y naught plus h minus f of x naught, y naught divided by h. This will gives you rate of change of f of x comma y in the direction y at the point x naught, y naught. Note, first point, same thing. The partial derivative of f or z with respect to y is denoted by dou f by dou y, same thing, or fy, dou z by dou y, or zy. The partial derivative of f or z with respect to x at some point with respect to y. So with respect to y, at some point x naught, y naught is denoted by dou f by dou y at that point, or simply fy. That means partial derivative with respect to y at the point x naught, y naught, or simply dou z by dou y at x naught, y naught, or zy at x naught. The partial derivative dou f by dou y at some point gives the rate of change of f with respect to y when x held fixed at x naught. Now x is constant because you are doing derivative with respect to y. Now y is a variable, x is constant. This is the rate of change of f in the direction of the positive y-axis now at the point, or in the direction of the vector j. That means in the y-axis. J vector is the unit vector in along y-axis. So same thing again, dou f by dou x at some point x naught, y naught is similar to d by dy of, since you are doing derivative with respect to a, that means you are treating x as constant, then substitute x is equal to x naught. Now this is a single variable function. Now this is a curve. So f of x naught comma y is a curve. F of x naught comma y so is a curve. Curve z is equal to f of x naught y naught. X naught comma y. At the point x naught y naught and f of x naught y naught in the plane x is equal to x naught. This is in the direction y. In the direction y. Now look at geometrically. So this is x axis, okay, and this is y axis, and this is z axis, okay. Now look at this is the surface. Z is equal to f of x comma y is the surface. This is the surface. Black one is surface. Now look at this blue one. This blue one is a curve. This blue one is a curve. Look at the curve z is equal to f of x naught y in the plane x equal to x naught. You are substituting instead of x, x naught. Now this gives you a curve. This blue one is a curve. For this curve, you are doing derivative with respect to x. Therefore, this tangent slope you will get. This pink color one is a tangent at this point. What is this point? X naught, y naught, f of x naught, y naught. At this point, you are finding tangent. And slope of this line is nothing but d by dy of f of x naught, y naught in the y direction. Look at, since this is y direction, this is y axis, right? Look at, this is y axis. Therefore, in this direction only, look at, this is the direction. Tangent direction is in y direction. Now you are finding slope in y direction. Okay, so this is the geometrical meaning of partial derivative with respect to y. Next, dou f by dou x and dou f by dou y are said to be first order partial derivatives. First order means only one time you are doing derivative with respect to x or y, whatever. That is called first order partial derivative. Next one, second order partial derivative. Dou square f by dou x square. That means two times you are doing derivative. So this one you can write like this: dou by dou x of again dou f by dou x. So first you are doing the derivative with respect to x. First one, this is. After evaluating first with respect to x, then again you will get one function, then again you do with respect to x again. So this is called fxx. Suffix xx, that means two times derivative, or simply this means first you do derivative with respect to x, after that do derivative with respect to x. This is first, this is second one. First with respect to x, after that again one more time with respect to x. Okay. Second one, dou square f by dou y square. Again same story, dou by dou y of again dou f by dou y. Again same story. First with respect to y, second with respect to y. So first with respect to y, after that second with respect to y. Third one, dou square f by dou x dou y. So dou by dou x of dou f by dou y. That means first with respect to y. First with respect to y. After that second with respect to x you have to do. So the function is given to you. First with respect to y you have to do derivative. That means treating x is constant in this. Treat x is constant and y is derivative. Example. Look at f of x comma y. For example, just x plus y minus 1. Now, dou f by dou x means what? With respect to x, you have to do derivative, treating y is constant. Everything is constant, only x is variable now. So, x is variable, all these are constants. Now, x derivative is 1 plus. What is y derivative? 0, because you are treating y is constant, right? So, therefore, dou f by dou x of y is 0 and this is 0. So, finally, this answer is 1 only, that's it. Like this. So that means you are treating x is a variable, remaining all are constants. That's why this derivative of these two becomes 0. Only you are treating x is variable. Therefore, dou f by dou x is 1, like this. So now in this you have to treat y as a variable, remaining all are constants. With respect to y you have to do derivative. After that, with respect to x you have to do derivative. So here with respect to y you have to do derivative. With respect to x is second. So this order you have to remember. F by x means first with respect to y you have to do derivative, after that x, like this. First with respect to y, after that x. That means what? First with respect to y, then you will get a function fy, then this fy with respect to x you have to do. Similarly, dou square f by dou x, same story. Dou by dou y of dou f by dou x. That means first with respect to x, second with respect to y. First with respect to x, second with respect to y. Look at first with respect to x, after that you will get a function, then you have to do with respect to y. Second with respect to y. These are the orders. Are said to be second order partial derivative, because every time you have done two times derivative, first with respect to x, next with respect to y, or first with respect to x, again next with respect to x, or first with respect to y, next again with respect to y, like that. So two times you have done derivative all this in all these things. That's why these are second order partial derivatives. Okay. Look at problem number 1. Find the first order partial derivatives of the two variable function y into e power minus x from the first principles. First principles means by the definition. Okay. By the definition you have to proceed. Okay. I want first order partial derivatives. That means dou f by dou x and dou f by dou y So these are the question marks because these are the first order partial derivatives. Okay. But how by first principles I have to proceed. First principles means by definition. So what is dou f by dou x? So dou f by dou x is nothing but limit x tends to 0. Now with respect to x in f. So variation in x coordinate. That's why f of x plus h you have to write. F of x plus h comma y minus f of x comma y divided by h. So this will gives you dou f by dou x. This is called by using definition or first principles. Okay, limit h tends to 0. F of x plus h comma y and minus f of x comma y divided by h. Now let me proceed this. So which is limit h tends to 0. Let me write here what is f of x comma y. So this is f of x comma y. So f of x comma y is y into e power minus x. So this is f of x comma y. Now what is f of x plus h comma y? So wherever x, there you write x plus h, and wherever y, there you write y in this function. So instead of x, you write x plus h. Instead of y, just y only. So y into e power minus of x plus h. Wherever x, there I am writing x plus h, nothing else. Minus f of x comma y. That means y into e power minus x only. Divided by h. Okay, divided by h. It is same like you have done already derivative. What is the first principle of df by dx? So limit h tends to 0. Already you have seen this one in PUC. F of x plus h, f of x plus h minus f of x, right? F of x divided by h. Yes or no? This is if f is a single variable function. This is a formula for derivative, fundamental formula for derivative. Or directly, for example, f of x equal to x square plus 1. This is a function. By using this principle, you can calculate the derivative. Or directly, since variation in x, right? So therefore, with respect to x, I will do derivative to x directly. Or like this also you can do it. There are two techniques. One is by using principle. One is direct attack. Variation with respect to x like that. But since it is single variable, that's why x plus h and x. Variation x coordinate you are doing. Since it is two variables, but particularly with respect to x, that's why with respect to x only I am doing variation. If it is with respect to y, then here x only you have to write, but here y plus h and here y. Variation in y you have to do. Okay? Yeah. So this is equals to, now let us simplify limit h tends to 0. H tends to 0. Yeah. So y into e power minus x to e power minus h minus y into e power minus x divided by h. Now we are doing derivative with limit with respect to h. Therefore, remaining all are constants. Let us take y into e power minus x is common here. So if you take y into e power minus x is common, I am sending that outside because it is irrespective of limit. Limit is only for h only. Therefore, h terms you write inside. Limit h tends to 0 e power minus h minus 1 divided by h. So this will left in this after taking y into e power minus x common in the numerator. Okay. Now you proceed. So y into e power minus x. Okay. And now apply limit h tends to 0. What will you get? E power 0 is 1. 1 minus 1 is 0 by 0. So 0 by 0 you are getting. So once you are getting 0 by 0, then what you have to do? Don't say path limits. Why? Because it is a function of single variable only. If it is a single variable, go to L'Hospital rule. If it is a two variable function, then go to path limits or simplifying the function. So L'Hospital rule. Okay. Then yeah, apply. So numerator and derivative separately and denominator derivative separately. Numerator derivative e power minus h derivative minus into e power minus h and minus 1 derivative 0 minus 0 divided by h derivative is 1. Now you have to apply the limit. Again, if you are getting 0 by 0, again one more time you have to go to L'Hospital rule. So y into e power minus x. Now apply limit h tends to 0 here. So what will you get? Minus e power minus 0 by 1. What will you get? Minus 1. So answer is minus y into e power minus x. So this is by using first principle. Therefore, dou f by dou x value is minus y into e power minus x. Okay. Similarly, with respect to y, that means dou f by dou y. Now variation y. So therefore, limit h becomes 0 or h tends to 0. F of x comma, I have to do variation in y coordinate, y plus h. minus f of x comma y divided by h. Okay, so now let us, yeah, and this is limit h tends to 0, h tends to 0, yeah, f of x comma y plus h. So what is the function? Y into e power minus x, right? This is the function. And what is f of x comma y plus h? Wherever y, there you write y plus h. So therefore y plus h into e power minus x, e power minus x minus y into e power minus x, f of x comma y as it is, divided by h. Okay, now this is, so limit h tending to 0, yes. So y into e power minus x, isn't it? Plus h into e power minus x minus y into e power minus x whole upon h. Now in this, these two cancel out because these two are similar terms. Y into e power minus x minus y into e power. So then what will you get? So therefore limit h becomes small, h becomes 0, h into e power minus x divided by h. Now again h cancel out. So therefore finally what will you get? Limit h tends to 0, limit h tends to 0, you will get just e power minus x. Okay, that means it is irrespective of limit. Okay, so this I can write, yeah. So this I can write e power minus x is completely outside because that is irrespective of limit. Limit h tends to 0, nothing is there means here 1. 1 into e power minus 6, like, so e power minus 6 is out, now 1 is remained. Now limit of a constant is constant itself, therefore e power minus 6 into 1, e power minus 6. So this is dou f by dou y. With respect to y you are doing derivative. Okay, without using first principle you can do like this also. So by using first principle means compulsory you have to evaluate like this only. Okay, you can evaluate like this also without using first principle. That means what is dou f by dou x? By geometrical meaning of this, with respect to x you have to do derivative treating y is constant. Now y is my constant. Okay, so dou by dou x of y into e power minus x. What I have to treat? I have to treat y is constant. So once y is constant, then y will comes out dou by dou x of e power minus x. Okay, what is that? E power minus x derivative is minus e power minus x. So minus y into e power minus x. That's what I got just now. Look, this is without using first principles. Next one, dou f by dou y. Dou f by dou y. That means dou by dou y of what is f? Y into e power minus x. Okay. Now we are with respect to y we are doing derivative. Therefore x is constant. So once x is constant, x terms you send completely outside. E power minus x is out, and dou by dou y of y. Only y terms you have to keep inside. What is the derivative of dou by dou y of y? 1. So e power minus x. Look at I got e power minus x here. Look at e power minus x like this. So this is direct attack without using any principal formulas. Now this is by using principal formulas. Okay. Next one. Problem number 2. Find the first order partial derivatives of f of x comma y at 2 comma minus 1. So first order partial derivatives means dou f by dou x and dou f by dou y. So first dou f by dou x. Dou f by dou x. That means dou by dou x of what is f? X cube plus 2 times x into y minus y raised to plus 1. Now apply separately the partial derivative. So dou by dou x of what will get? X cube. Dou by dou x of x cube plus dou by dou x of 2xy, okay, minus dou by dou x of y square, okay, and plus dou by dou x of 1. Now this is dou by dou x of x cube. That means with respect to x you have to do derivative treating remaining all are constants. But here fortunately you are having only one variable. So therefore dou by dou x of x cube is nothing but 3x square. With respect to x only I am doing derivative. Plus again with respect to x only you have to do derivative. That means treating remaining all are constants. That means 2 into y you send outside. 2 into y I am sending outside. dou by dou x of with respect to x. Only x terms you keep inside. That's it. And this one dou by dou x of y square is 0 because there are no x terms. How to write this one? You can write like this also. Simply, since y square you send out because that is irrespective of the derivative. So dou by dou x of nothing is there means inside is 1. Y square into 1, right? So 1 I am writing. Y square I am sending outside. And plus dou by dou x of 1 is 0. Constant derivative is 0. Now this is 3x square. Okay. Plus 2y into 1. Dou by dou x of x is 1 minus y square into dou by dou x of 1 is 0. That's why 0 into y square is 0 I am getting. Okay. So finally you will get 3x square plus 2y. That's it. So this is partial derivative with respect to x. Or you can do it by using first principle also. It becomes somewhat lengthy, but you can do by using first principle also. Now, but what I want with at some point 2 comma minus 1 I want, right? So therefore dou f by dou x at the point, which point 2 comma minus 1, 2 comma minus 1 is how much? So 3x square plus 2y. This is dou f by dou x, and at what point? At 2 comma minus 1 I want 2 comma minus 1. That means x is equal to 2 you substitute, y is equal to minus 1 you substitute. What do we get? X is 2. So 3 into 2 square is 4 plus 2 into y is minus 1. Then simplify. 12 minus 2 is 10. So this is indirectly this is the slope of the curve at x is equal to in the x direction. So y is equal to minus 1. So in the plane y is equal to minus 1 in x direction the slope is 10. Okay. Similarly, I want dou f by dou y. So dou f by dou y. Again same story. With respect to y, how to evaluate? Treating x is constant. So dou by dou y of function f is, what is f? X cube plus 2 times x into y. Okay, minus y is raised to and plus 1. Now again you elaborate this. So what will you get? Dou by dou x of x cube, or directly you can evaluate. For more clearance I am writing like this, or directly you can evaluate if you are understanding. Minus dou by dou y of it with respect to y, or doing derivative with respect to y. So dou by dou y of y square. Next plus dou by dou y of 1. Then what do you get? First one, dou by dou y of x cube is 0, right? Next plus dou by dou y of this one. That means 2x is constant as it is, but y derivative is 1. So 2x into 1 is 2x. Like this you can do directly, no problem. Minus with respect to y, y square derivative is 2y, and this one derivative is 0. So finally answer is 2x minus 2y. 2x minus 2y. Okay. Now to the point 2 comma minus 1. So dou f by dou y at point 2 comma minus 1. 2 comma minus 1. 2x minus 2y at the point 2 comma minus 1. 2 comma minus 1. That means x is 2, y is equal to minus 1. So 2 into 2, 2 into 2 minus 2 into minus 1. So 4 plus 2 is 6. So this is a slope in y direction at the point 2 comma minus 1 comma. After substitution 1 point, we'll get one more point. At that point, slope is 6. Okay. Next one. Find fx and fy if f of x comma y is this one. Again same with respect to x and y, you have to do derivative. So we can proceed like this. So fx is nothing but dou f by dou x, right? Dou f by dou x. Dou f by dou x. Now with respect to x only, you have to do derivative. So dou by dou x of, now what is f now? Substitute f value here. F is fraction 2y by y plus cos x. Y plus cos x. Now since it is u by v format, so therefore with respect to x, u by v, again what is u by v? Derivative of u by v. So v square derivative of u by v. Derivative of u by v, okay, is equals to v square, denominator is v square, and numerator derivative first u dash into denominator as it is v, minus numerator is as it is, denominator derivative v dash. Now since it is partial, right? So dou of u by v. How to do this one? Dou by dou x of this one. For example, with respect to x. Again same story. V square you have to write with respect to x. So first numerator derivative. That means numerator derivative only. Instead of writing u dash, I am writing dou by dou x of u. V is as it is minus u as it is dou v by dou x, like this. Same story only. Here I am writing v dash. V dash means with respect to x or y, whatever. But here particularly dou by dou x, right? That's why with respect to x particularly. Same thing. Again dou by dou y of u by v. How to attack this? Again same story. First v square. First numerator derivative. So denominator as it is and numerator derivative with respect to y. Dou u by dou y minus. And numerator as it is, denominator derivative dou v by again dou y, like this. Same story, but with respect to y or x we have to fix. So here divided by y plus cos x, y plus cos x whole square, denominator whole square. Next denominator as it is, y plus cos x I am writing as it is, y plus cos x I am writing as it is. Numerator derivative I have to do with respect to x only. So dou by dou x of numerator function is 2y. The second one minus. Now numerator as it is 2y and denominator with respect to y, dou by x, right? With respect to x, dou by dou x of denominator is y plus cos x, y plus cos x. Now simplify this. What will you get? Y plus cos x is as it is, y plus cos x, y plus cos x, and dou by dou x of 2y is 0. With respect to x you have to do derivative. That means treating y is constant. Now this is a constant. 2y is a constant, so derivative of constant is 0. Minus 2y as it is, and dou by dou x of y plus cos x. So y plus cos x means y derivative 0 because y is constant in this. Plus cos x derivative with respect to x is minus sin x. Minus sin x. And whole divided by y plus cos x, y plus cos x whole square. Okay. Now this is equals to y plus cos x into 0 is 0, right? Minus of minus plus. So 2 into y sin x. 2 into y sin x divided by y plus cos x whole square. So this is fx. This is fx. Okay. Next let us calculate what is with respect to y, fy. So dou f by dou f by dou y. Same story again, but with respect to y you have to evaluate. Okay, that means dou by dou y of what is f? Then replace f, that is 2y by numerator is 2y, denominator y plus cos x. Y plus cos x. Okay. So with respect to y you have to evaluate this. Now again same story, u by v. Okay. So divided by y plus cos x whole square. Y plus cos x whole square. First numerator derivative, that means denominator as it is. So y plus cos x is as it is. So we should not derivative this. Numerator first derivative, that but particularly with respect to y. So dou by dou y of 2y. Okay. Minus. And numerator as it is, denominator derivative with respect to y. That means dou by dou y of denominator. What is that denominator? Y plus cos x. Y plus cos x. Okay. Now this is exactly equals to, now simplify, y plus cos x, y plus cos x, yeah, dou by dou y of 2y is 2 because y derivative is 1. With respect to y I am doing, that means x terms are constant, but luckily here there are no x terms, minus 2y into dou by dou y of this one. Now what will get? 1, first one is 1 because with respect to y you are doing derivative 1, cos x derivative 0. Why? Because it is x term. Dou by dou y of x term is 0 because x is constant in this, divided by y plus cos x whole square. Y plus cos x whole square. Now this one after simplification what will get? So this is 2 into y plus cos x minus 2y. That means what? 2y plus 2 cos x. First one. 2 into y 2y, 2 cos x minus 2y divided by y plus cos x whole square. Y plus cos x whole square. Okay. Now these two cancel out. 2y and minus 2y cancel out. So finally, we will remains with 2 cos x divided by y plus cos x whole square. Y plus cos x whole square. That's it. So this is partial derivative with respect to y. Okay. Next one. Find dou z by dou x if y into z minus ln z is equal to x plus y, where z is a function of x and y. So z is a function of x and y. That means it is an implicit function actually. Implicit. Implicit means the variables are hidden. So in z, variables are hidden. Z is a function of x and y. So implicit function, that is particularly z is a implicit function here. Z is implicit function. Okay. Now, how to find this kind of? So first, what is given? Y into z minus ln z is equals to x plus y. Okay. Now y into z is a function of x and y. Therefore, I can write like this: z of x comma y, because z is a function of x and y. Look at here; it is given. Z is a function of x and y minus ln of, okay, z of x comma y. Z is a function of x and y is equal to x plus y. Now here x and y are independent variable. That's it. Z is independent variable. Like z is equal to x plus y. For example, look at this function. X and y are independent variable. Z is dependent. If you know x and y value, then only you can calculate what is z value. That's why z is depending, right? This z is depending on x and y. That's why it is depending variable. And these two are independent variables. X and y are independent variable. Okay. In the same fashion here also, x and y are independent variable. Z is dependent variable. But what I want here, what I want now actually, dou z by dou x I want, right? Dou z by dou x I want. So therefore, from here, I want dou z by dou x sides. Apply both sides dou by dou x. Okay. Now dou by dou x of yz. Simply I am writing z. Z is a function of x and y minus ln of z. Okay. And this side dou by dou x of x plus y. Okay. And now what is this? So now you are doing derivative with respect to x. That means what? Y is constant. Okay. Z is a function of x and y here. Okay. Now with respect to x you are doing, therefore here y is constant, therefore y is 0. So in this, let me write y is constant. Okay. So here also y is constant. Y is constant because you are doing derivative with respect to x. Then what you will get here? Dou by dou x of this one, first one. So UV method you have to apply. First with respect to y derivative and z as it is, right? So z as it is dou by dou x of y. I am applying UV method. Listen carefully. And plus y as it is dou by dou x of z. UV method. So what is UV method? D of UV. Derivative of UV is u v dash plus v u dash. Okay, first v as it is u derivative, next u as it is v derivative. This is uv. Same thing I am applying here. For z as it is y derivative, next y as it is z derivative over minus dou by dou x of ln z. Okay, is equal to dou by dou x of x is 1, dou by dou x of y is 0. And here z as it is dou by dou x of y is 0 plus y as it is dou by dou x of z. Don't say 0. Why? Because z is not a constant. Z is a function of x and y. Okay. Z is a function of x and y. Therefore, what is dou by dou x of z? Dou z by dou x simply. Okay. Y into dou z by dou x minus dou by dou x of ln z. First 1 by z, and by chain rule z derivative is dou z by dou x by chain rule. Okay. For example, look at here. I will explain. What is d by dx of ln 2x? Now, what is d by dx of ln 2x? 1 by 2x first of all. Okay, and 2x derivative is 2, right? Same thing I am doing here. By chain rule, 2x derivative is 2. Same thing, ln z derivative is 1 by z and z derivative is dou z by dou x here into dou z by dou x. So same like I have done 2. Okay. Now this is exactly equals to 1. And if you simplify this, let us take dou z by dou x is common. What will get? Y minus 1 upon z is equal to 1. So this is our required answer. Therefore, dou z by dou x value is dou z by dou x. And simplify here, you will get y into z minus 1 by z is equal to 1. So if you simplify this, you will get dou z by dou x is equals to z by yz minus 1. So this is dou z by dou x value. Okay. So if there is any implicit function, you see, so here z is implicit function, you can attack like this. The final goal is I want what is dou z by dou x, and that you take outside like this. So here I want dou z by dou x in this, then I have taken dou z by dou x is common because I want what is dou z by dou x. Look at the question, I want dou z by dou x. That's why I have taken here dou z by dou x common. Then I am finding what is dou z by dou x. So this is a partial derivative of z with respect to x. Next one. The plane x is equal to 1. Listen carefully. I will show you this in geometrically. The plane x is equal to 1 intersects to the paraboloid z is equal to x square plus y square in a parabola. Okay. Let's take this is x-axis. Okay. This is x-axis, this is y-axis, and this is z-axis. Now z-axis is central axis, therefore x square plus y square. Therefore x square plus y square means this one. So this is the paraboloid. Okay. Now the plane x is equal to 1. So x is equal to 1. This one is cuts this one. Like this it cuts. It cuts in a parabola like this. So this is a parabola. So this is a parabola. That's what here. The plane x is equal to 1 intersects the paraboloid z is equal to x square plus y square in a parabola. So it's cutting in a parabola. And find the slope of the tangent to the parabola at 1, 2, 5. So somewhere you will get the point 1, 2, 5. So at this point on the parabola, you have to find a tangent and slope of this tangent I need to find. Okay. Now look at in two dimensional, for example, x-axis and y-axis. Let's take x-axis and y-axis. X-axis and y-axis. For example, in this x equal 1 means what? X equal 1 means the line passing through the point 1 which is parallel to y-axis, right? This is parallel to y-axis. So this gives you x equal 1. This is a line equation actually. This is a line equation. But if you look at here, x-axis, y-axis and z-axis. But if you look at here, x is equal to 1 means not line. It is a plane now. So now look at here. In this, x is equal to 1 means parallel to y-axis. Now here x is equal to 1 means it is parallel to, now two axes are there, y and z. So it is parallel to yz plane now. Here in here x is equal to 1 means parallel to y axis only, because only one axis is there, that is parallel to y axis. Here two axes are there, y and z. So it is parallel to both y and z plane now. That means you will get this kind of plane. So this plane, it is passing through one and it is parallel to this yz plane. So here what is yz plane? So this entire thing is a yz plane. So this is yz plane. So and this plane is exactly parallel to this yz plane. So now in 3D, x equal 1 means not line. So this is x equal 1. This is x equal 1. X equal 1 is a plane now in 3D. But in 2D, x is 1 means it is a line. Okay. In one dimensional, x is 1 means line. In two dimensional, x equal 1 means plane. Yeah. Now look at this one is graphically. That means I want the plane x is 1, intersect the parabola at z is equal to x square plus y square in a parabola. Find the slope of the tangent of the parabola at 1, 2, 5. Let us look at this geometrically. Yeah, look at here now. I want square plus y square. So this is a paraboloid x square plus y square. So look at this is a paraboloid x square plus y square. Now look at in this figure. This red line shows x-axis, okay, green line shows y-axis, and blue one is z-axis. Okay, red one is x-axis, green one is y-axis, and blue one is z-axis. Okay, now next I want x is equal to 1. Now look at in this, what is meant by x is equal to 1? Look at x is equal to 1 means plane it is. Look at x is equal to 1. Let us change the color so that it will be very clear. Sorry. Yeah. Now look at this. So this is a plane y is equal to 1. Okay. So this is a plane y is equal to 1. Pink one shows, look at, sorry, x is equal to 1. So I said already, this red line means x-axis, green line means y-axis, right? So red line is x-axis. Therefore, look at x is equal to 1, it is passing the plane. At x is equal to 1 passing, but it is parallel to this yz plane. Okay. So now this plane is cutting this paraboloid at where, look at paraboloid. So this is the it is cutting the paraboloid in parabola. Look at, so this is a parabola. So this one is a parabola. So it is cutting here like this. So this one is parabola. Understand? So this entire thing is parabola. So from here to here. So this is a parabola. So this is a parabola. So this is intersecting like that. Look at the plane is cutting the parabola. Look at it is cutting like this from the middle. Okay. So therefore it is cutting in parabola. So this is a parabola. So this is a parabola. And what I want tangent at what point 1 comma 2 comma 5. Now let us look at what is the point 1 comma 2 comma 5. Where it is 1 comma 2 comma 5. Okay, 1 comma 2 comma 5. Now look at where it is. Look at the figure. Look at point A, blue color one. Look at this is lies on this parabola only. Look at here marking here. Look at. Okay, so this one. So this is a point blue one. The point A is where it is lying. It is lying on this parabola only. Okay, on this parabola it is lying. Therefore, at this point the tangent will be like this. So this tangent, at this point you have to find the tangent, and that slope you have to calculate. Understand? So therefore, so before that I want to elaborate this. 1 comma 2 comma 5 means 1 comma 2 comma 5 is means it is x naught, y naught, and f of x naught, y naught, right? F of x naught, y naught. That means after substitution the point x naught, y naught in the function you will get z value. Z value is nothing but f of x naught, y naught. So let us substitute that. So z is equal to x square plus y square. Okay. Now that means what z means, z of x comma y. Don't get confused. Which is x square plus y square. But here z or simply f whatever. Or you can write f of x comma y, your wish. We can call f of x comma y also, no problem with that. So therefore, what is here x naught, y naught? The point x naught, y naught is, which is simply 1 comma 2, right? Substitute 1 comma 2, what do you get here? So z of 1 comma 2, x naught, y naught I am substituting. X naught, y naught is 1 comma 2, then 1 square plus 2 square. How much it is 5? Look at 5 I am getting here. 1 comma 2 comma 5. That's why it is x naught comma y naught comma f of x naught, y naught. Okay, it is clear now. So now in the plane x is 1 is cutting. X is 1 means this one, x naught is 1. X naught is 1 is cutting. Therefore, in the y direction, look at this is a tangent in which direction? Look at the graph. In y direction only you are calculating the slope, right? Therefore, dou y by dou y you need to calculate. Dou by dou y of z you have to compute. In the y direction you have to compute the slope. So therefore, dou by dou y of what is z? Z is here x square plus y square. Clear? Compute it with respect to y. So that means x is constant in this. So dou by dou y of x square is 0 plus 2y. So therefore, this answer is 2y. 2y. Okay, which one? Dou z by dou y. So then, what I want slope, right? Therefore, dou z by dou y at what point x naught, y naught, right? X naught, y naught. X naught, y naught is simply dou z by dou y. X naught, y naught means here what the point? Point is 1 comma 2. That means x is 1, y is equal to 2. But what is dou z by dou y? It is 2y. 2y from 1 comma 2 at 1 comma 2. What is y is 2, therefore 2 into 2 4. So therefore slope in the y direction is 4 units. So this is 4 units of slope. Okay, next one. And last problem, with this I will stop. Problem number 6. Now what I want, dou f by dou z. So here dou f by dou z. How to evaluate this kind of again? So it is inside, the z is hidden inside. So dou by dou z of x into sine of y plus 3z. Okay. Now with respect to z you are doing, with respect to z is a function of three variables. Look at x, y, z. Now with respect to z you are doing means what? That is x and y are constants. X and y are constants in this constants. Okay. Now let us proceed. So this is dou by dou z of x into. So since x is constant, we write outside dou by dou z of what is left? Sine of y plus 3z. See, for example, here instead of x, if you are having z, for example, z into sine of 3 y plus 3z, for example. Okay, instead of x into sine y plus 3z, you write z into sine of y plus 3z. Now dou by dou z of this one. Now you supposed to apply uv method compulsory because z is a variable and inside also z is a variable. Therefore uv method you have to apply. But since here x is constant, I'm sending outside, so uv method is not required here. Now, yeah, x into dou by dou z of this. First of all, sine derivative is cos of y plus 3z. Again by chain rule, y plus 3z derivative with respect to z. So dou by dou z of, let me write clearly, dou by dou z of y plus 3z. Again inside function derivative by chain rule. Like just now I told you what is d by dx of ln 3x. d by dx of ln 3x derivative how much? It is 1 by 3x. And again 3x derivative is 3 you are writing. Indirectly its meaning is d by dx of again 3x you have to do like this actually. Its meaning is this. That means 1 by 3x into d by dx of 3x is 3. So this is the final answer for that. Same story here. First of all, sine derivative is cos of y plus 3z. Again, dou by dou z of y plus 3z. So now this becomes x into cos of y plus 3z, cos of y plus 3z, and dou by dou z of this one is 0 plus 3 because y is constant here. I have already written here x and y are constant. So y is 0 and 3z derivative with respect to z is 3. So finally answer is 3x cos of y plus 3z. So this is the final answer. Okay. And with this I will stop.